Water heaters. We'll have all the elements of the story. Airbags. The tale of how they're made is about to unfold. Jelly beans. We're really going to spill the beans about them. And ice resurfacers. We'll have the cold, hard facts. The residential water heater was invented back in 1889, and the basic concept still holds water today. It heats water, usually with natural gas, propane, or electricity. Then it keeps it continuously hot, so that you always have a supply on tap. Life without it would mean a lot of cold showers. Water heaters may look uninspiring, but inside, they're hot stuff. To make one, a hydraulic press transforms a round steel blank into a dome shape. This dome will form the base of a gas-heated tank, and it will hold the burner. Next, rollers behind and above curl a sheet of steel around a cylinder. This forms the inner tank shape. A seam welder device then pinches the two ends of the tank shape together and welds them. In the next step, a worker positions the tank body under a projection welder. He selects a threaded fitting, places it on the tank, and lowers the welder. This projection welder uses 10,000 volts of electricity to fuse fittings to the tank body. It also welds fittings to the top of the tank. Valves and other parts will be screwed into these fittings later. Next, a press applies over 27 tons of force to fit a top onto the tank. Then they spray liquid enamel inside of the spinning tank. It will be baked in at 900 degrees Celsius for 45 minutes to prevent rusting. Now it's back to the bottom of the tank. A worker inserts a flue tube in a hole in the center, and an automated welder joins it to the tank base. The flue will vent gases from the burner. After anti-rust enamel coating is baked onto the base and flue, they lower the tank body onto it. Next, robotic welding arms work both ends of the tank. One welds the base to it, the other bonds the flue to the top. Now, the pressure test. They pump air into the tank and then pour water over the outside. If water bubbles on the tank, it means air is escaping and there's a leak that needs to be fixed. Here, they install elements in an electric water heater. And they hook up a thermostat and the wires that run to it. Now it's time to make the tank's outer shell or jacket. An operator slides a painted steel shape onto a mandrel so that it becomes cylindrical. A lock former then moves along a rail, folding and pressing the seam together. Next, a roll former crimps the top and bottom edges so that lids can be easily installed. Here, they drape a plastic apron over a tank and then slide on its jacket or tank shell, with just the electric components exposed. They screw a steel cover over them. Here's a demonstration of what's next. A chemical reaction causes polyurethane foam to expand in seconds. They inject this expanding foam into the plastic apron that's now between the tank and outer shell. The foam will insulate the tank. Now they finish installing the wiring on this electric heater. And then do an inspection. It makes the grade. On gas heaters, they slide a burner into the dome-shaped base and then connect the burner tubes to the gas valve. They attach some wiring that controls the burner ignition and then hook it up to the gas line for a test run. That inner glow is the burner at work. They light a torch on the flame and pass it over the valve to check for little gas leaks. It didn't ignite, so there aren't any. It gets the seal of approval, and now it's up to the consumer to test the waters when it's installed. The airbag was invented in the 1960s, but it wasn't an instant smash hit. It took several years to trigger a big reaction. But by the 1980s, automakers were installing them in most vehicles. Sensors detect a sudden deceleration and inflate them, giving vehicle occupants a soft landing. This side curtain airbag inflates in less than 20 thousandths of a second. Blink and you'll miss it. Making an airbag is practically a seamless effort because they're woven in one piece. Big computerized looms weave at a blurring speed, 600 revolutions per minute. They're called air-jet jacquard looms. They lift and lower each nylon yarn to make an intricate one-piece fabric. Up to 10,700 yarns can be used to make the material. If even one of the thousands of yarns breaks, an electrical sensor will detect it and shut the loom down, so production never gets in a snarl. Despite this rapid weaving action, the loom produces just 8 meters of fabric an hour. That's because it's very dense fabric. That density will allow the airbag to stand up to the force of deployment. Now the woven fabric goes through an inspection station. As automated rollers wind it up, a worker examines it. If it's acceptable, he signs it off. Next, it's on to the scouring station. Here, a machine unwinds the airbag fabric as rollers guide it towards a wash and dry system that's 36 meters long. The rollers draw the airbag material through a number of big wash tanks to ensure a thorough cleaning. Then a series of hot rollers dry and press the fabric. The freshly laundered airbag material moves through the coating machine. A hose pumps liquid silicone onto the fabric and a scraper overhead distributes it. As a worker scoops some up, you can see that it's as thick as molasses. The silicone seals the airbag fabric, but it's wet and sticky and needs to dry. So it passes through a series of ovens heated to about 190 degrees Celsius. As it dries, the silicone cures to the fabric. Now, a computer-guided laser cuts the material with a precision and speed that no human could ever replicate. Black lines woven into the fabric assist the laser as it cuts the airbag design. At any point in time, it's cutting multiple airbags out of the fabric. When the job is done, the conveyor belt moves the airbags forward. And now they're scrutinized by humans. A worker pulls the one-piece airbag across a template and examines it to make sure the dimensions match. Then it's sent over to the sewing station. Although the airbags have been seamlessly woven, attachments and reinforcements still need to be sewn on. The stitching is computer-controlled. A worker feeds the fabric to the sewing machine and then simply presses a button. The machine stitches together the tabs that will connect the airbag to the inside of the vehicle frame, just above the side window. Here, it sews a tether onto the bag. This strip of fabric will also be used to hold the airbag in place. Now it's time to test a sample airbag from the production run. And yes, we have ignition. The jelly bean is colorful, but its beginnings are a bit of a gray area. No one is sure exactly when the jelly bean was invented or how. It's believed that the jelly center dates back to biblical times and a candy called Turkish Delight. Many centuries later, the outer shell was added, and the jelly bean was on its way to sweet success. The jelly bean is a sugary sensation. Billions are sold at Easter alone. To make jelly beans, they heat liquid sugar in a big kettle to about 175 degrees Celsius. They add glucose, which is a more concentrated sugar, and then starch. An agitating device mixes it all together. While elsewhere in the factory, starch spills out of a drum onto big trays. A leveler moves back and forth to even out the starch on the trays. The trays then move forward, and a brush knocks off the excess starch. It will be recycled. A molding board now presses down into the starch. It makes 756 jelly bean impressions in the starch in each tray. The impressions in the starch will serve as molds for the jelly bean centers. Nozzles inject the sugar and starch mix cooked in the kettle into the starch molds. This system can make almost 1 million jelly bean centers an hour. Next, the conveyor belt takes the jelly bean centers to the drying room, where they stay for 24 hours. This solidifies them. They become chewier. Arms flip the trays of dried candy centers and starch and dump them into a big drum that will separate them. When the trays flip back, they're refilled with starch and the molding process begins again. Meanwhile, the dried jelly bean centers, now separated from the starch, tumble out of the drum onto a wire mesh conveyor system. It transports them to a steam belt which dampens them. This readies them for the next step, sugar coating. The jelly bean centers go into a sander drum that tosses them around, while nozzles spray them with sugar. In another part of the factory, liquid sugar flows out of a kettle into a tub. A worker adds blue food coloring to the syrup, and then he blends it in. This mix is called engrossing syrup. He adds the engrossing syrup, along with some flavoring, to the jelly bean centers as they tumble around in a tilted spinning pan. After they turn a very sticky blue, the worker dumps some sugar into the pan. This process is repeated 4 times in order to build up a coating around the gummy center. The next day, when the beans have hardened, they add hot syrup to the mix and toss the beans around again. This polishes the jelly beans. There's a lot of sweet stuff here. 124,000 jelly beans in each pan. Now he adds a little wax. And as the pan spins, the beans rub against each other, distributing the wax. This adds gloss to the polish. Then the pan stops spinning, and the jelly beans air dry for 24 hours to allow the glaze to set. It's the finishing touch. After 3.5 days, this big batch of jelly beans is ready. They move in a multicolored mass along a series of conveyors. They fall into a scale system that portions them out for specific bag sizes. Then a trapdoor opens and they drop down a chute to the packaging department. Once they're in the bag, the jelly beans are ready to sweeten your day. In just minutes, the ice resurfacer can smooth things over after hockey roughhousing. But it wasn't always so easy. Before it was invented in 1949, it took several workers over an hour to resurface the ice, using scrapers, squeegees, and hoses. Now that's a long time between periods. The ice resurfacer is in a league of its own, scraping, cleaning, and flooding the ice in just a few turns around the rink. To make an ice resurfacer, they weld together steel pieces to build the main frame. The frame has to be very strong because it will support everything from the engine to the water tank. It's a load of almost 3 tons. Sparks fly as they grind smooth the areas where parts will be mounted. The sparks are actually steel fragments being sanded off. Next, they weld support braces with holes in them to the center of the water tank. These are called baffles, and the holes will allow the water to flow into both ends of the tank. Now they slide a piece of spiraling steel, which is auger flighting, on one end of a pipe. And they slip a piece that twists in the opposite direction on the other end of it. They weld a U-shaped paddle to the pipe between the 2 steel spirals or flightings. The paddle is a critical part. The flightings will feed ice shavings to it, and the paddle will then toss them to a bin mounted above a water tank to be disposed of later. Next, a worker clamps the flighting to a hydraulic cylinder. He turns a lever, and hydraulic energy pulls the clamp, drawing the auger flighting snugly to the pipe. As the clamp holds the flighting in position, he welds it to the pipe. Now they're solidly sealed together. Next, another worker places a long steel blade on a magnetic table. The magnets hold it down, while a grinding machine moves over it, sharpening the edge. Because the grinding generates heat, the machine also floods the blade with water. This cools it down so the steel stays hard. Now, using a crane, they lower an engine onto the frame that we saw welded together earlier. Then they slide the rear drive shaft into place and bolt it down using a pneumatic wrench. The tires for an ice resurfacer will need some serious traction. Each tire gets 92 of these metal studs. They drop the studs into a revolving feeder. The studs funnel down a tube to the stud gun, ensuring that it never runs out of ammunition. The road these tires travel will be nothing but a sheet of ice, and these studs should allow them to stay the course. Next, using a crane, they transfer the water tank to the center of the frame. The snow bin, which will hold the scraped ice, is next. They place it on pivot points at the front. Then workers slide the blade into place. They bolt it tightly, working from the center outward. The workers are shielded from the very sharp blade by a plastic sleeve that sheathes the edge. When the blade is secured, they remove the plastic. Now it's time to give the ice resurfacer a test run. The steel flightings twist towards the paddle at the center, as they should. Here's a close-up of that razor-sharp blade that will shave the ice. A rectangular scraper slides over the flightings, preventing snow from building up and clogging the system. This ice resurfacer is now ready for the limelight, and it's sure to be the biggest smoothie on the ice. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.